As science consistently improves our understanding of the world, scientific method is constantly being improved also. Scientific method is a process in which science is carried out where it builds on previous information with newer, improved scientific information, thus gradually becoming more effective at generating new knowledge. 1,000 years ago, Alhazen demonstrated the importance of forming questions and then testing them. This approach was also adopted by Galileo in 1638 with the publication of two new sciences. The following method is based on a hypothetico-deductive model which was formulated in the 20th century but has gone through drastic changes since first proposed until now. Falsification was first introduced in 1934 to reduce confirmation bias by formulating an attempt to disprove a hypothesis rather than prove it. The process involves making conjectures, predicting from them logical consequences, then carrying out experiments to determine if the original conjecture was correct. A conjecture, of course, is another word for hypothesis. It is difficult to make a statement of method composed of formula. Scientific methods are generally set up on fixed sequences of steps, but they are also considered general principles, and not all steps take place in every scientific inquiry or at the same degree. They are not always in the same order either, and invention, soundness of judgment, and a natural, exceptional capacity of intelligence is needed at every step of the process. The question can pertain an explanation of the specific observation. For example, why is the sky blue? Or open-ended like, how can I invent a cure for a certain disease? Looking up previous experiments and evaluating evidence, observations, assertions, and previous work from other scientists is also a part of this stage. If this question is already answered, another question that builds on the previous evidence can be presented. When applying scientific method to scientific research, finding a good question can be difficult, but affects the outcome of the investigation. A hypothesis is a conjecture based on knowledge obtained by forming the question that may explain the observed behavior of a part of our universe. It may be specific or it may be broad. A statistical hypothesis is a conjecture about population with terms associated to it referred to as null hypothesis and alternative hypothesis. A null hypothesis is that the conjecture of the statistical hypothesis is false, or also meaning that nothing is presented and the effects are by chance. Researchers want to show that the null hypothesis is false because the alternative hypothesis is the desired outcome. A scientific hypothesis must also be falsifiable too. meaning that a possible outcome from an experiment that conflicts with the hypothesis prediction can be identified, making it not possible to be meaningfully tested. This step requires determining the logical consequences of the hypothesis, and one or more predictions are selected for further testing. The more unlikely the prediction would be correct simply by coincidence, the more likely it would be convincing if the prediction is fully developed. Evidence to the prediction is also stronger if the answer isn't already known, due to the effects of hindsight bias. Ideally, the prediction should distinguish the hypothesis from likely alternate. If two hypotheses make the same prediction, observing the prediction to be correct is not evidence for one or the other. The statements about relative strength of evidence can be derived using Bayes' theorem mathematically. Testing is an investigation on whether the real world behaves according to the predictions of hypotheses, determined through experiment to see if the observation of the real world agrees or disagrees with the predictions of the hypothesis. If they agree, confidence in the hypothesis increases, and if they don't, it decreases. Agreement also does not mean that the hypothesis is true, because future experiments may reveal problems, and that is why falsifying hypothesis is suggested. To search for and test experiments that would seem most doubtful, because the large number of successful confirmations are not convincing if the experiment avoids risks. Experiments should minimize errors through the use of appropriate scientific controls, such as double-blind tests. Test personnel are also kept ignorant of what is being handled to prevent biased response from test subjects. Failure of an experiment doesn't necessarily mean that the hypothesis is false, because experiments generally require multiple hypotheses. That the test equipment is working properly, and a failure may be a failure from one of the extra hypotheses. Experiments can be done virtually anywhere, from the kitchens to the bottom of the sea and into space or on other planets. Most individual experiments involve highly specific topics for reasons of practicality. As a result, most evidence of topics that are broader are usually more generally accumulated. Analysis involves deciding what the result of the experiment shows and what the next actions to take are. The predictions of the hypothesis are compared to the null hypothesis in order to decide which is better for explaining the data. In cases where a lot of experiments were performed many times, statistic analysis such as chi-squared may be required. If the evidence falsified the hypothesis, another hypothesis must be required. If the experiment supports the hypothesis but the evidence is not strong enough for high confidence, other predictions from the hypothesis must be tested. Once a hypothesis is supported by strong evidence, more questions can be added for further insight into the same topic. Evidence and experience from other scientists are frequently added during any of the stages of the process. Depending on the complexity of the experiment, repetition may be required to gather sufficient evidence strong enough to answer a question with confidence. Also, to build up many answers to highly specific questions in order to answer a single broader question. This model underlines the modern scientific revolution.